Welcome to Cosmic Compass, where we journey together through the wonders of the universe, from the mysteries of distant planets to the bold missions that carry us into space. This is where stories of exploration come alive. Today, let's take a closer look at Orion and Artemis, the pennon of the mission that marked humanity's return to deep space after nearly half a century. It was more than just a test flight. It was a declaration that the moon and beyond is once again within our reach. Humanity has always been drawn to new frontiers. In the 16th century, when Christopher Columbus crossed the Atlantic, thousands of Europeans followed. They sailed for months across dangerous oceans, leaving behind the comforts of their world for an unknown land. Many did not survive, yet more and more kept coming. Why? Because the call of the frontier was stronger than fear. Fast forward to the 21st century, and before us lies a new frontier, space. Unlike the oceans, this is not merely challenging, it is utterly hostile. In space, there is no breathable air. Temperatures can burn or freeze you in an instant. Radiation seeps in, ready to alter or destroy the cells of your body. Gravity itself becomes your enemy, crushing your bones or wasting them away. And yet, here we are, drawn to this place, as if something deep within human nature compels us forward. Why would anyone want to build a home in a place so desolate? Perhaps it is the challenge, perhaps it is curiosity. After all, while photographs and instruments are valuable, nothing compares to standing somewhere feeling it for yourself. That is why our gaze turns toward the planets of our solar system. Mars may one day welcome human footsteps, but our first step begins closer to home at the moon. NASA's Artemis program has one goal: to return humans to the moon and use it as a stepping stone to explore farther worlds. The spacecraft at the center of this effort is Orion. In late 2022, Orion embarked on its first mission, uncrewed but critical. This was Artemis III. Its job was not to carry astronauts, but to prove that the spacecraft, its systems, and its rocket could survive the journey to the moon and back. If successful, the data collected would pave the way for Artemis II, the mission that will carry real people around the moon. This was more than a test flight. It was a promise that after nearly half a century since the Apollo program, humanity is ready to set foot on the moon once more. Of course, America is not alone in this ambition. In 2019, China landed a rover on the far side of the moon, a feat never achieved before. They have also been developing the Long March 9, a rocket powerful enough to carry astronauts to the lunar surface, perhaps in the 2030s. Competition is nothing new in space exploration. The Apollo missions themselves were born from the space race of the 1960s. Today, that spirit continues. For NASA, Artemis is not just about exploration, it is about leadership. They intend to be the first nation to return humans to the moon. But for that to happen, Orion's maiden voyage had to succeed. Orion's mission was designed as a complex retrograde orbit around the moon, meaning it traveled opposite to the moon's own orbit of Earth. It would swing past the moon 3 times, including 2 close flybys, testing navigation, communication, and life support systems. This was no symbolic flight. It was a rigorous trial to prove that Orion could one day carry astronauts safely through deep space. Every piece of technology had to perform flawlessly. Although no humans were aboard, Orion was not empty. Its most notable passenger was a mannequin named Mannequin Campos. Packed with sensors, it was there to record radiation levels and stresses astronauts would face. The name honoured Arturo Campos, an engineer who helped save Apollo 13 after its oxygen tank exploded. Alongside Campos were 2 more mannequins designed with different body types, representing female astronauts who will play a vital role in future missions. Their presence highlights an important fact: space affects each body differently. Testing must reflect the diversity of those who will travel. Radiation in particular is a daunting challenge. On Earth, we are shielded by the atmosphere and magnetic field. On the Moon, exposure can reach up to 380 millisieverts per year, nearly 8 times the maximum safe human dose. Finding ways to protect astronauts is essential. Campos and his silent companions carried the burden of this test. To get Orion into space, NASA used the Space Launch System, or SLS, the most powerful rocket in the world today. At liftoff, it unleashed 3.8 million kilograms of thrust, capable of sending 70,000 kilograms of cargo toward the Moon. It dwarfed even the legendary Saturn V in certain aspects, making it NASA's flagship vehicle for the Artemis era. The mission was packed with experiments. Some were expected, others surprising. For example, Orion carried Alexa, the voice assistant, as part of a project called Callisto. Imagine calling out to a spacecraft hundreds of thousands of kilometers away and asking for its flight status. It sounds like science fiction, but it happened. Technicians on Earth held conversations with Alexa aboard Orion, demonstrating how voice-controlled systems might one day support astronauts. On the third day, Orion began inspecting itself. Micrometeoroids are a constant threat in space, small fragments, traveling faster than bullets. Cameras scanned the hull for damage, ensuring the spacecraft could survive long voyages. Fortunately, damage was minimal. As Orion approached the Moon, it flew over historic Apollo landing sites, Tranquility Base, Apollo 12, and Apollo 14. It was a symbolic passing of the torch from the generation that first reached the Moon to the generation preparing to return. Perhaps the most critical test was Orion's autonomy. For 15 minutes, as the Moon blocked Earth, Orion was completely cut off. No radio, no guidance, no support. Could it navigate on its own, just like sailors once used the stars to cross the oceans? Orion used an optical navigation camera. It identified constellations, compared them with onboard star maps, and calculated its position. Tested again and again, the system worked flawlessly. Orion proved it could guide itself even in silence. NASA also tested how liquids behaved in Orion's tanks. It may sound trivial, but predicting the movement of fuel in microgravity is notoriously difficult. Engineers call it sloshing. The data Orion collected will refine how future spacecraft maneuver. Meanwhile, the thrusters themselves were tested again and again, fine-tuning the spacecraft's delicate lunar orbits. These engines performed better than expected, bringing Orion within just 130 kilometers of the Moon's surface. Not everything was perfect. On day 8, Orion unexpectedly lost contact with Earth for 47 minutes. On day 19, its heaters and propulsion systems briefly failed. Both issues were resolved, but they reminded NASA that space travel will always be filled with risks. After nearly 4 weeks, it was time to return. Re-entry into Earth's atmosphere is one of the most dangerous phases of any mission. Orion would test a maneuver called skip re-entry. Like a stone skipping across water, it dipped into the atmosphere, bounced back out, then re-entered again. This technique slowed it down, allowing a precise splashdown point, but the danger was immense. At re-entry, the air around Orion ignited, turning into plasma hotter than 800 degrees Celsius. Radio signals vanished. For a few minutes, NASA could do nothing but wait, watching the clock, holding their breath. Then, as expected, Orion emerged from the plasma sheath. At 2,900 meters above sea level, parachutes deployed in sequence, first small stabilizers, then drogues, then massive main chutes. They slowed Orion from over 200 kilometers per hour to a safe landing speed. On December 11th, 2022, Orion splashed into the Pacific Ocean. Recovery teams aboard the USS Portland moved in. Hours later, engineers inspected the spacecraft, testing how seawater and extreme heat had affected its systems. Inside, mannequin Campos and the other mannequins had survived unscathed. Artemis I had done its job. Orion proved it could survive the journey to the Moon and back. Its systems worked, its heat shield held, its thrusters performed with precision. The data collected from its mannequins and instruments will inform every step of the Artemis program. Soon, real astronauts will sit where Campos sat. They will feel the vibrations of launch, the silence of lunar orbit, and the fiery return through Earth's atmosphere. For humanity, Artemis was more than a mission. It was a statement that we are ready to take our first steps back into the cosmos. The frontier still calls, and we are answering, and so Orion's part in this story is complete. But for us, the journey is only beginning. The Moon, Mars, and beyond, these are the horizons waiting for us. If you enjoyed this mission recap, you might like exploring other stories of space exploration. You can find them in our playlist. A big thanks to all of you who support this channel. It helps us continue bringing these cosmic journeys to life. Until next time, let's keep looking upward, because the story of the stars is also the story of us. Thank you for joining us on this journey. Artemis I and Orion have shown us what's possible when science, engineering, and human curiosity come together. If you enjoyed this video, don't forget to subscribe to Cosmic Compass for more explorations of space astronomy and the frontiers of human discovery. Leave a comment to share what part of Orion's mission fascinated you the most. We'd love to hear your thoughts. Until our next journey together, keep your eyes on the stars. The universe is vast, and we've only just begun to chart its paths.